Number 9, how many solutions does the following system have? So again, you can use different methods. You could use substitution, elimination. You could solve these by graphing, graph them both and see how many times they cross. Or you can use your matrices, which I feel like is kind of the quickest way to do it. So I'll show you how to do that. Go to Matrix, go to Edit. This is also a 2 by 3. And then we have our numbers 3, 2, and 1. -9, -6, and 3. Math. All right, now you will notice that when we do this, we've got 1.6700 0 and 1. So because the ones don't line up, you might have noticed from number 8, the question we just did, that these should line up to say, okay, my x is equal to this number and my y is equal to this number. So this one doesn't do that. So that means we have two options. Either there's no solution, or it could be infinite solutions. Okay? In order to be infinite solutions, you need to have the exact same line. So it would need to be, for example, 3x plus 2y equals 1, and some magnification of that. So, for example, if I multiplied everything by 2, I would get 6x plus 4y equals 2. That would give me infinite solutions, because really when you graph them, they're the same equation. So we've eliminated b and c. Those are not options. When I look at these, are these really the same equation? So is there a number I can multiply all these by to get the second equation? So you might say, okay, well, if I do 3 times -3, I get -9. And if I do 2 times -3, I get -6. But 1 times -3 is not 3. So these essentially are not the same equation. If you graph them, they're not going to be right on top of each other. So my answer is no solution. Okay. And again, you can always also, solve both of those for y and go ahead and graph them. You'll have infinite solutions if they graph right on top of each other, 2 solutions if they cross in 2 places, 1 solution if they cross 1, and if they never cross, if they're parallel, then you're going to have no solutions.